Hey Algebra 2 peeps, hope everything went well with your notes that I posted earlier this week. I know I said I'd post the notes video every Monday. I ended up not being able to post it until Tuesday morning. Sorry, I had some issues, but I bet you'll forgive me. Again, you're doing this at your own pace, so you may not have even looked at the notes video yet, and that's okay. Go back to Google Classroom, follow along with me. Today's video will be even a little shorter because this is just the practice, which is all the evens 2 through, what do we have, 22? All right. So go back, look at the notes. You can try the practice without me, or you can just follow along right now. But anyways, we're on 4.4 practice, which is factoring polynomials, and we're starting at number 2, which just says GCF. You should have looked at these two numbers first. And you should have figured out that the GCF between 16 and 28 is 4. Then you look at 2R's and 5R's and realize the most you can pull out is 2, because this has 2R's, and this has at least 2R's. It actually has more than 2, but then you got to figure out what's left. I'm actually going to divide both of these terms by the GCF, which is 4R squared. Negative 16 divided by 4 is negative 4. 2R's up top, 2R's on bottom cancel out. 28 divided by 4 is 7. And then R to the 5th divided by R squared. Remember, you take these two things and you subtract them. You get R to the 3rd. So here's your answer. Hope you got that. Again, this one was just pulling out GCF. For number 4, I hope you didn't spend too much time on this because there is no GCF. It is not factorable at all, actually. Between 5, 4, and 3, I can't pull out a number. And this has 3 V's, 2 V's, but this last term has no V's, so I can't pull out any V's. On number 6, you should have figured out your GCF was 4x squared. It's got 4 different numbers here. So, between 8, 12, 12, and 28. Notice I'm kind of ignoring the negatives for a hot second, because I'm just looking at the numbers, not the negative or positive sign. But between 8, 12, 12, and 28, the GCF is 4. Then you look at 9x's, 4x's, 3x's, and 2x's. The smallest exponent is going to be what you can pull out. Because I can pull 2x's out of here, and here, and here, and here. But as soon as I try and pull more than 2 x's, I've run out of x's here. So now you just got to figure out what's left. You take every single term and divide by that 4x squared. 4x squared, 4x squared, 4x squared. You should have gotten negative 2x to the 7th plus 3x squared plus 3x minus 7. That is your final answer. Done. Now shifting down to number 8, the instruction said no leading coefficient, meaning there's nothing here, right in front of the x squared. There's nothing. Okay. Zoom in a little bit. There we go. So, what we talked about is the fact that that means I am going to factor into 2 different binomials, and the only thing I need is a t-chart. We talked about in the video on Monday that this middle term right here goes here, or the middle coefficient, and then the last one here goes here. Oh, and I am sorry, I put a multiplication sign here. That should be an addition sign. If you want more practice, you can Google this. It is called a product sum table. Or we talked about in class how this is also sometimes known as the AC method, but I would just Google factoring trinomials, or factoring polynomials, whatever. In this case, this is a trinomial, so that's what we're doing. But anyways, I need 2 things that multiply to a negative 32 and at the same time add to a negative 4. You could have listed every single factor of negative 32 and you should have gotten negative 8 times a positive 4. Those 2 things will add to a negative 4. So because there's no leading coefficient, all you got to do is say x minus 8, x plus 4, and I'm done. There's nothing else to do with that problem. You can, if you want to double check, go back and multiply these 2 things out. You can use FOIL, you can use the box method, or you can use the distributive property. But if you multiply these two things out, you will get back 2x squared minus 4x minus 32. All right, number 10, same thing. T-chart. I want two things that add to 5, but that multiply to a negative 50. Now these, I'm looking at 10 times negative 5. Done. Again, you could have listed everything that multiplies to a negative 50, and there's only two numbers that will multiply to negative 50 and add to 5. N plus 10, m minus 5. That's my final answer. I am done. Okay, number 12. Slightly more fun. I got slightly larger numbers, but nothing too crazy. If I look at my T-chart, I need two things that add to a negative 14, but multiply to 48. Add to the middle. Multiply to the thing at the end, and remember we're talking about no leading coefficient. Nothing in front there. Now, this you've got to use logic because you need two numbers that multiply to give you something positive, but simultaneously add to give you something negative. So you have to realize you need two negative numbers here. This would have been a negative 6 and a negative 8. I guarantee you, some of you, your brains are going to work this way. You're going to see it right away. Other people, you're actually going to need to list out every single factor of 48, and that's okay too. So my answer being, oh, it's not an M. Whoops. It is a B. B minus 6, B minus 8. Done. Okay. Shifted down to number 14. If you look at the instructions, it says look for a GCF first. Look for a GCF first, then use a T-chart. So, I mean, when you take the SAT next year, because remember, you juniors who didn't get to take it this year, you will take it next year in the fall. And the SAT will not tell you if there's a GCF first. You'll just have to remember to look. Now this, GCF of 5, and when I pull out a 5, I'm left with n squared minus 9n minus 10. Some of you, I think, at this point aren't even going to make the T-chart, and you're just going to say two things that multiply to a negative 10, add to a negative 9. And you can just write it down. It would have been n minus 10, n plus 1. But again, if you need to come off to the side and write out a T-chart, there is absolutely nothing wrong with that. It's a tool that I'm giving you to use. And you could write out, let's see, 1 times 10, 2 times 5, but I know one of them has to be negative because it's actually a negative 10. So 1 times a negative 10 or 2 times a negative 5. And only one of those actually adds to negative 9, like I want. So this is my final answer. Very important. Do not forget this 5. That thing that we originally pulled out is part of your answer. If you had done the whole thing and then just wrote n minus 10, n plus 1, you are wrong. Because if you take these three things, multiply them back together, that gets you back to 5n squared minus 45n minus 50. All right, let's keep going. Now we're getting to the more fun stuff. Notice I have a number in front. Just like number 14. 14, I had a number in front. But with 14, I pulled out a 5 as a GCF. And then once I'm looking at this stuff on the inside, ignoring the 5, I no longer had a number in front. Well, with number 16, hopefully you realize there was no GCF. So then you had to do the T-chart table thing. T-chart. Sorry, not table. Box. Everyone's favorite. Adds to still this middle number, multiplies to these two multiplied together, 2 times 8. Then you were looking for negative 1 times the negative 16. These are my two magic numbers is what I always called them in class. Oops, sorry. Negative 1, negative 16. So negative 1x, negative 16x, Those are not part of the answer. Those go in the box. Top right, bottom left. It does not matter which goes where. First term, 2x squared, goes in the top left. Last term, positive 8, goes in the bottom right. Your answer is going to be what comes up on the top here and the left here, and that comes by pulling out GCFs. So let me look at the two on the right. I know this is negative, so this is going to be negative. And between 16 and 8, I can actually pull out an 8. Now if we look at the two on the left, this is positive, so this is going to be positive, and the only thing I can pull out is an x. Now I'm going to look at the two on the top. Between 2x squared and negative 16x. Well, I know I can pull out an x, but I can actually also pull out a 2. And the two on the bottom, this is negative 1x, so therefore whatever I pull out is going to be negative. And some of you are going to look at this and say, well, 1 and 8, there is no GCF. Technically, there's always at least a GCF of 1. So when we say there's no GCF, we mean no GCF other than 1. But this is one of the few cases where a GCF of 1 is helpful. So my final answer here is x minus 8, 2x minus 1. Which you could double check by multiplying together. Which, look, it's done right here. Box method. And then if I were to squish these two things together, negative 1x, negative 16x, I'd get back to negative 17x, and I have actually gone backwards to what I originally started with. 18 might have confused a few people. Should have done it in one of two ways. Maybe you recognize this as a special case. This is a dots, difference of two squares. Meaning, my answer is 2x plus 1, 2x minus 1. Which you get from saying, what's the square root of 4x squared? 2x, 2x. What's the square root of 1? 1, 1. Plus, minus. That's if you remembered that this was a special case. If you did not remember that this was a special case, you could have said, well, this is the same thing as 4x squared plus 0x minus 1. 0x in the middle. Then I'm going to do the same thing. T-chart. Add to 0, multiply to negative 4. That is a negative 2 and a positive 2. And then I would do the box. First term, last term, and then that negative 2 and positive 2 go in the top right, bottom left. Doesn't matter which goes where. And when I pull out GCFs, sorry, that would be a positive 1, 2x, 2x, and a negative 1, and you'll notice I got 2x plus 1, 2x minus 1, done. All right, let's show you this one more time. So, for number 20, you would say, I want two things that are going to add to 4, and two things that are going to multiply to 4 times negative 15. Which just about all of you have phones, so you can use the calculators on there. I'm not too concerned about it. Okay. And the two numbers that you should have been looking for here are, what is this, 10 and a negative 6. Because 10 multiplied by negative 6 gives you negative 60. At the same time, 10 add negative 6 gives you 4. That's what goes into my box. 10, negative 6, but don't forget whatever variable, in this case that's an x. First term goes in the top left. Last term goes in the bottom right. And I pull out GCFs. I'll slow this down a bit. If we look at the two on the right, I can pull out, looks like a 5. Two on the left, they both have at least one x. But between 4 and 6, I can also pull out a 2. Top 2, they both have an x. Between 4 and 10, I can also pull out a 2. Little hint here, 2x multiplied by 2x gives you 4x squared. That should make sense. That's box method stuff. And on the bottom, since this is negative, whatever I pull out is going to be negative. And between 6 and 15, the biggest number I can pull out is a 3. I cannot pull out any variables because this sucker doesn't have any variables. So my answer, 2x plus 5, 2x minus 3, I don't even care if you rewrite it. If you don't want to, if you just want to leave it on either side of the box, that's cool with me. Okay. Very last problem. I showed you on the notes portion this little, oh, I actually wrote that wrong. Here. That should be a B, sorry. I showed you on the notes video that this is what's called a difference of two cubes. This is new, but the good news is it's just a formula. But what you did have to realize, and I gave you this hint first, is to look for a GCF first. So in this, you actually should have pulled out, what is it, 9n cubed. That's your GCF. If you pull that out, you're left with n cubed minus 729. Now, this is the same thing as n cubed minus 9 cubed. 729 is a perfect cube. So now this and this, those are the two things you want, n and 9. So every time you see an A, you'll plug in n. Every time you see a B, you'll plug in 9. So n minus 9, n squared plus n times 9 plus 9 squared. And if I simplify that, I get n squared plus, you can write that as 9n plus 9 squared is 81. Do not forget, always, 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 if you ever pulled out a GCF, that needs to be part of your answer. So 9n cubed should have been part of your answer. Your final answer being 9n cubed times n minus 9 times n squared plus 9n plus 81. That is called the difference of two perfect cubes. You could Google that if you want. All right, that's the end of this practice. Next week on Monday, I will release the notes video for 4.5, which is solving quadratics by factoring. It's very similar with one extra step. Again, notes video will come on Monday. Practice video will come on Wednesday. I hope you're following along with this. Please email me if you need any help with anything, academic or not. All right, miss you all. See you soon.